In this series, we want to take a closer look at technologies, system solutions, and industrial reality. How do we develop and deploy technologies that are not only scientifically sound, but also efficient, scalable, and ready for industrial implementation? To start this series, we want to focus on technology that addresses exactly these challenges. For this, today I have my honored guest, Mr. Jürgen Rechberger from AVL. He's Group Vice President of Fuel Cell and Energy at AVL. More than 23 years with AVL in fuel cell technology, in energy, and I assume energy transition also. Thank you to have you here. First question, which stages of your career have been most formative for your work today?
First, thanks very much for the invitation to this exciting podcast. So for me, my career had different stages, and I think all of them had influenced actually my path. So I have started actually in the music industry as a DJ, living in New York, which was exciting. Then I moved on to the next stage, which was more in business related, in business consulting in McKinsey, living in Los Angeles. Also there I learned a lot, actually, which I can use today. And but then I got super excited in California about sustainability. And I had the feeling that at McKinsey, the consulting company, I cannot have that impact I wanted to have. So I switched to a tech company. And at this point in time, AVL started this whole thing about hydrogen. And I joined this activity. And obviously there, of course, over these 20 years, I went through different stages and also learned a lot. But I would say that all of these three phases I took with me. And I think the constant in my life is really finding new solutions, going new paths, creativity and innovation.
You said you wanted to go into energy transition, and I saw on your LinkedIn profile that you started with fuel cell technology. So you started in the, I would say, early days of this development, not of the fuel cell, but of the implementation on a wider sector. Because back in the days, fuel cells in the 80s were for space and space travel, to have energy source on board. Now we are talking about switching to hydrogen systems, converting hydrogen back to power, back to electric power, where fuel cell is one of the most essential parts. So what made you back then see the bigger picture of this technology?
I'm not sure if I really saw the big picture already, right? So when I started the whole thing, it was still more related to mobility. So in the, let's say 20, 25 years ago, nobody was really concerned about climate change or CO2, right? It was more air pollution. California was really fighting air pollution. So nitrogen oxides and things like that. That was priority one. And they implemented the first zero emission mandate to bring in zero emission vehicles. So I would say the first half of my career was really focused still on mobility. And we were mostly working also on fuel cell solutions for cars at the beginning. We were part of very big programs to develop such solutions. And then it moved a little bit more to heavy duty truck because the advantage there has been recognized as being bigger. And only I would say in half of, or let's say after 10 years at AVL, it got more into this CO2 reduction, into using hydrogen for various other things, for energy applications and for hard to abate sectors, which then actually accelerated a lot because today 80-90% of my business is in hard to abate sectors and not in mobility anymore.
It's clear. I fully understood one question on that because you said anti-air pollution. I've been last year to the Schwarzenegger World Summit in Vienna, and there he made, I think, a pretty bold statement, which is great, to rebrand CO2 emissions to air pollution. So tell the people no, we're not reducing CO2, we're reducing air pollution, and we should less pollute the air with new technologies. What's your thought on this rebranding, or this try to rebrand?
I think I'm not sure if it's the right way to tackle it because it has completely different impact, right? Even with the traditional harmful emissions, we always had a harmful impact on persons, on the environment. That's per nature not the case with CO2.
At least not directly.
Not directly, yeah. A long term, of course, we have various long term effects. But how you brand it, I think the measures are key. What kinds of measures you implement, but I think we will get to this topic later.
Yes. One point, because you said you had a lot of stations and a lot of intermediate steps. What are you currently working on with this background, and what is your role in that?
So today I'm running one of 4 business units at AVL. So VL is in principle an engineering and technology provider, and we have 4 business divisions. 3 of them are still focused on our traditional legacy business in automotive. It's vehicle engineering, it's engine development, and it's electrification products. But we see as the main diversification area for AVL is energy technologies. Therefore, we established also a business unit on hydrogen fuel cell and energy technologies. And so I'm in charge of this global business unit, driving this global business in this area.
Mm-hmm. And to expand also the know-how of AVL into sectors that have not currently used or currently exploited.
Sure, absolutely. That's one of the main topics. It's definitely new areas for AVL. I mean, AVL has been in some non-automotive markets. For example, we have done traditional always business in the marine sector, in the rail sector, a little bit in the aviation sector, to some extent also in the energy sector, but very minor in a very small niche with gensets, engine-based gensets. But now, of course, it's a completely different exercise. We need to really make AVL a brand also in the energy technology area. I'm working basically with completely new customers for AVL in complete new industries, but that's my job. So I have my job is mainly really drive the diversification.
That's great to hear, because back in the day when I was in technical college, AVL was the one Austrian technology provider for mobility. For a lot of what I knew was car mobility. Now you're going really into industrial systems, which is very amazing to see. In the beginning, you told us you want to solve structural problems in the energy sector, like that is not renewable, which is, in my opinion, a structural issue of that. What are structural problems in addition to that you see need to be solved in the energy sector?
I mean, the structural problems of energy, it always depends a little bit from which viewpoint you see it, right? Where you are positioned on the globe. Because in the Middle East, you would see that completely different than in Europe. But from a European perspective, I think we have 3 big issues. One, on the one hand side is we are highly depending on energy imports, right? So that's one of the biggest issue. The second big issue is energy prices are very high in Europe, so we need to keep them affordable. And then, of course, we have the sustainability issue, right? And I think these 3 elements from a European perspective, we need to work on. I don't think we can, at least the first one, solve completely. Europe will always be depending on energy imports, but we could do it in a smart way, diversified, right? Not being too dependent on one partner. So strong diversification. That's for sure what needs to be addressed. I think the cost issue is a little bit structural and also not easy to solve. But I think the key here is really local renewables, at least for the electricity prices. We need to make much more effort to accelerate this buildup. And sustainability is basically the heart of what I do. That's really shifting, in particular, hard-to-abate sectors to clean molecules or to electricity. I think for the, let's call it easy-to-abate sectors, it's pretty straightforward, right? Nobody's questioning anymore that the way to go for individual mobility is electric mobility. But the real challenges I see in the hard-to-abate sectors.
Yes. This already takes one of my questions I had for the back of the podcast. Electro or ICE? And I think I can now answer this. It's electro for you, for personal transport.
Yeah, for me, definitely. I drive since years an electric car. I'm absolutely convinced that's the way to go. I think it's the I would say, even superior technology today compared to ICE. I mean, there will be a niche for ICE. Perhaps we can get some renewable fuels into this sector with HVO or with e-fuels or whatever it is. So we can create a small niche, but I think electric mobility will dominate.
I honestly, I fully agree with that. I also have now an e-car, and I'm fully convinced. Talking about technologies, you at AVL, your daily business is develop technologies and roll them out. the core of your business is improving. So what are existing technologies? Why are they not sufficient? Especially in the focus of the ICE or of energy systems.
Yeah, even the easy answer is because there's competition in the market, right? Everybody comes with new products, with new features to gain market share, to increase margins. So there's a strong competition in the market. It's, I would say, even stronger in the automotive sector than in the energy technologies. So they are really battling each other with features on the car, with prices and things like that. And of course, also with technology progress, right? With increasing efficiency. Actually, the driving force for innovation in the automotive sector in the last, even I would say 30, 40 years was really the emission regulations. Because there was a legal mandate that you need to meet certain emission regulations, right? That's more or less gone with electric vehicles. So now the trend here is different. It's obviously some functional parameters of the car, like range, like energy consumption, but also very important are more, let's say, psychological effects like drivability, how fun to drive, and in particular also connectivity of the car with all the features you need. Where I think we lost a little bit track over China.
I fully agree. I have a European car, and there's a quantum leap between Chinese technology and European technology at this point. So just to sum it up, I understood that in your opinion, efficiency is the key to a new technology. Why is the new technology superior to the old one is efficiency, I would say.
I would say in energy technologies, yes, it's probably the key. In cars, it's one factor of a lot of factors, right? If the drive cycle efficiency is 2% better than compared to another, you would not buy it because of that, right? So it's more important, obviously, in trucks because OPEX is dominating on trucks, right? Operating costs. So fuel savings are really important there, and 1%, 2%, 3% efficiency improvement on a truck means a lot in total cost of ownership. In pace car, I would say it's largely irrelevant. Of course, you should not be out of range, right? But I think it's really a driving factor in these energy technologies. Because if a gas turbine is 5 or 8% more efficient, that's a significant impact on TCO.
Yeah. One point I want to highlight and I want to ask you is, with your deep insights into the industry, what is a thing that most people overlook overall? So in the overall debate, what is mostly overlooked in your opinion?
I think what at least in the last years, I would say in general that the awareness of climate change has gone down significantly, right? It's even getting a little bit unpopular to speak about it, but still with all these distractions we have with these geopolitical issues and things like that, I think the focus is now somewhere else. But I still believe, and I think this is something which we lost a little bit track of, I think still believe the biggest threat for the whole planet is climate change. Because it will cause so much consequential damages in migration flows, because we will make parts of the world uninhabitable, right? It's no more possible to live there because it gets too hot all the year long. So it will cause lots of immigration flows. It will cause a loss of wealth of people because we need to pay for the consequential damages of climate change. So it's a very, very significant, it will have very significant impacts. And I think we lost a little bit track in dealing with that properly.
Technology should solve what we as humanity somehow brought us into, I would say.
Yeah, there are two things. I think, of course, technology can help us, and I think it's the key. But on the other hand side, also the improved technologies with better efficiency, for example, enable easier business cases, right? Because without business cases, nobody is going to do it. Or there are some mandates in place, some legal mandates. But the key is also to make this whole climate change thing and to these new technologies, transfer that into working business cases.
So a working business case could be, for example, a new kind or a more efficient kind of electrolysis.
Exactly, yeah. So bringing down the cost of the product,
Mm-hmm.
because that's a little bit the showstopper today. Why the adoption is not faster specifically for hydrogen-based products is that the production cost of the product are too high,
Mm-hmm.
and you basically don't find the necessary off-takers for that. And if you now have technologies where you can bring down the cost by half or so,
Mm-hmm.
it's going to be easier to find off-takers.
Mm-hmm. So would be the better technology would be the ones that brings more bang for the buck, like co-electrolysis, for example.
Yeah, that's one example for some niche applications, right, where
Mm-hmm.
you need to go to a synthetic fuel, a carbon-containing synthetic fuel.
Mm-hmm.
But also for other applications, right? So we need to push really for efficiency. Also, very important these days is actually an application where efficiency is also important. That's on-site power gen, right? There's a huge trend into that. We see a huge hype with data centers. The electricity grids in US cannot support data centers anymore.
Mm-hmm.
So more or less all the new built data centers will have on-site power generation.
Mm-hmm.
So they build their own power plants that they can build a data center because they don't get access to the grid.
Mm-hmm.
And also there to make their, let's say, low emission technologies work, you need to improve the efficiency because inherently they are more expensive.
Mm-hmm.
And you can only compensate that with a higher efficiency by having lower OPEX costs.
Mm-hmm. So coming back to the technology, RFIL is at the moment, discovering, getting further on. What's the scientific core of the co-electrolysis?
Yeah.
As unscientifically as you can be.
Yeah, sure. Understood. I think before going to co-SOEC, I need to say a word about SOEC, right? Because it's in general, what we're working on is a new electrolyzer, which means what we do is electrochemical water splitting.
Mhm.
That's not really new. Everybody of us has seen that most likely in school with the Knallgas experiment. It's a well-established technology. In particular, what we are working on, as I said, is this solid oxide electrolyzer technology. That's an electrolysis process which works at very high temperature, which has the big advantage that it is inherently more efficient because according to the principles of this technology, at higher temperature, you need less energy. So there is an inherently efficiency advantage. In our case, we are now using a very special version of that, which is called co-SOEC. So, and that means that we are not only introducing water to the electrolyzer process, we are already adding also CO2.
Mm-hmm.
So we have a mix of water. In this case, it's steam because it's at high temperature. So we are mixing steam with CO2, introducing that in the electrolyzer. And we are now not only doing water electrolysis, we are doing in the same time also CO2 electrolysis.
Mm-hmm.
So we are converting carbon dioxide into carbon monoxide.
Mm-hmm.
So the output of our electrolyzer is a mixture of hydrogen and carbon monoxide. And that's exactly the gas composition we need to go in a downstream Fischer-Tropsch synthesis, for example, to produce a sustainable aviation fuel. So that's in principle the big difference to conventional electrolysis.
Mm-hmm. And why? Where's the basis in RFIL for that? Which insight made you think about this technology and this improvement of the SOEC technology, co-SOEC?
Yeah. That's a good question. We're coming to that because we have been working on this solid oxide technology, not for electrolysis, but for fuel cell.
Mm-hmm.
So you can use exactly the same technology for fuel cell, which, for example, is running. This is actually the technology we are applying at the moment for these data centers.
Mm-hmm.
So you convert natural gas in this fuel cell with 65% efficiency into electricity. And it's exactly the same principles of the technology.
Mm-hmm.
We are now just reversing the process. So we are using it not as a fuel cell, we are reversing the process and running it as an electrolyzer.
Mm-hmm.
And AVL, this was actually the first hydrogen technology AVL started to work on, was this solid oxide fuel cell.
Mm-hmm.
So we have 22 years experience on that, or even 25 years. And now we are transferring our knowledge from the fuel cell to the electrolyzer, which is actually a small step because it's had a lot of synergies.
So the saying that RFIL is always 10, 15 years ahead in technology now applies.
For this specific example, yes.
Now we see the results of that. Great. And you say you reverse your technology to be in the electrolyzer part of this production. When did it become clear that this works? I mean, there needs to be a long trail of experience, a lot of work behind this. What was your single point where you say, yes, this works, we'll do this?
That is actually not so long time ago. So we are investing in this solid oxide electrolyzer process already since, I would say, 10 years. For sure, in total, we have invested more than 50 million euros. And we had a big breakthrough about a little bit more than a year ago, where we for the first time demonstrated this co-SOEC process already a little bit upscaled, so not very on very small modules, so already on reasonable technical modules, that this works in a durability and functional performance test. And that gave us really the indication that this really is going to work.
And during this process, which were the biggest technical hurdles to overcome, if you can talk about that?
Yeah, sure, but it gets a little bit technical. So the problem in the co-SOEC process, because a lot of other companies also looked into it, but so far nobody else solved the challenge. And the biggest challenge is that is actually this gas composition of hydrogen and carbon monoxide, because from the physical equilibrium, you get in the operation very close to solid carbon formation.
Okay.
So you have a very small operating window where you can run without carbon formation. So you need to optimize the whole system. You need to have a very equal gas distribution, very equal temperature and pressure distribution, that nowhere in the whole system you form solid carbon, because this would be a showstopper. So it's a continuous optimization. It's not the one click, do you do that and it works.
Yeah.
So you need a very well proper designed system, very, very well homogeneous.
You mentioned 65% for natural gas conversion to electric power. What's the efficiency of now we're talking co-electrolysis, meaning from, of course you have to look at the whole process, but your process part, what's the typical efficiency and what's AVL's efficiency on the process in comparison?
If you only look on this one step, the co-electrolysis, the efficiency is extremely high. So we have measured recently slightly above 90%. That does not include the heat you need for the water vaporization, right? So if we exclude the water vaporization and say the interface is steam, then you get to efficiencies definitely in the range of 90%, even 91, 92% is possible.
But where does this efficiency come from? Just from the combination of the processes, from the combination of water electrolysis, or is there some trick behind we just don't see?
Yeah, it comes mostly it comes actually from the inherently high efficiency of solid oxide. So the ohmic resistance of the cell is, because of the high temperature, very, very low compared to other electrolyzer technologies. So therefore it has inherently a very high efficiency. So the trick now on our side is really to make the co-SOEC process work without any carbon formation. But the efficiency is more or less defined. Of course, proper design, you can play around with another 3, 4, 5%. But you are already with SOEC at a very high level of efficiency.
Yes. I just talked about the process change, so system integration. This technology produces synthesis gas, honestly saying. Where is this normally applied in the process? So not all of our listeners know the overall process chain.
Today it's not applied at all, right? It's in research state, but where we want to apply it is for green molecules for a hard-to-abate sector.
Okay.
And you can combine this process with more or less any kind of synthesis process you want. Our biggest developments we have at the moment, combination of our co-SOEC process with Fischer-Tropsch,
the classical way
with the objective to go to sustainable aviation fuels.
Yeah. Okay.
So we see at the moment in the market the biggest traction for sustainable aviation fuels, because there are blending mandates in place, so the industry has to use it.
Yeah.
Therefore, there are business cases visible, and therefore the biggest traction in the market. But you could produce other things with it. For example, e-methanol, even synthetic gasoline or synthetic diesel you could produce. So there are lots of ways. Basically, you could produce any kind of carbon-containing e-fuel.
Yeah, so the classical building blocks of synthesis gas can produce almost any hydrocarbon you want.
Exactly.
Like, for example, platform chemicals like e-methanol.
Exactly.
Yeah, very efficiently. But this brings me to the next question. Which industries, apart from aviation, which is clear, will benefit the most of this or of the overall technology transformation?
Mm, As I said, focus from us with all these technologies what we're working here are hard to abate sectors.
Mhm.
And there are some mobility applications, probably most important aviation. Then also shipping, right? Shipping needs clean fuels.
Yeah.
There is no way to do battery electric container ships going from Shanghai to Rotterdam.
Or to have
So,
carbon capture on the ship is also pretty challenging.
yeah, I don't believe in that as well. But so shipping is an important sector. Then also we see business cases for green molecules in long haul heavy duty trucking, but it's probably going to be more hydrogen than a synthetic fuel.
Mhm.
So that's basically, I think, the areas in mobility. Of course, there are smaller markets, niche markets, construction equipment,
Mhm.
and agricultural equipment where actually e-fuels would be the best way to do it.
Yeah.
But actually, we have more focus on other areas, and I think one of the biggest applicants of this technology will be refining. So in refining, you need a lot of hydrogen for upgrading products, for HVO production. So for a lot of things, you need hydrogen.
Yes.
And there is a trend, obviously, to make these products greener. And if you can substitute gray hydrogen with green, it helps you in actually making the product greener. And there are really good business cases, right? We see even in Austria with the investment of the OMV with the 140 megawatt green hydrogen for the refinery in Schwechat. So refinery is for sure one of the biggest off-takers. But then for sure also other areas like chemicals, plastics, right? For example, methanol could be a very important feedstocks for these industries.
Yeah.
Then not necessarily for co-SOEC, but for SOEC, we are already involved in various projects, for example, for green ammonia production, and in particular also for heavy industries like steel production.
Yeah. Yeah. So everything where we can switch or substitute fossil carbon or fossil energy carriers. Looking at scaling the technology. I mean, having it in the lab is fine. Having it as a demonstrator or as a pilot demonstrator is great. But the big breakthrough is having it in industrial size. What are the biggest challenges in scaling up the technology and how did you overcome that? Because in your view, in your business plan, scale up is the thing to do.
Yeah, but honestly speaking, the scale up for this co-SOEC is still in front of us. We have now demonstrated in the lab. We consider our technology be at technology readiness level 5. What we're doing right now as we speak is we are building 3 pilot plants already with, of course, they are small scale, but still in an industrial environment. So we're building even one in Vienna. There's another one in Saudi Arabia, and there's another one with an oil and gas company somewhere in Europe. So that will get us from TRL 5 to TRL 7 to have really a prototype in a real environment. And in parallel of that, we are also addressing the scale up. The scale up means for us much bigger co-SOEC modules, because at the moment they are rather small, and we need to make them significantly bigger that we can get towards really big building blocks for big plants. And that's the mission we have in front of us for the next 2 to 3 years. So it's at the moment not so much a supply chain topic and scaling supply chain and production. It's really still a technology topic to get from small modules to very big modules. And that's the focus in our development for the next 2 to 3 years. And then we believe that around 2028, 9, we can start to build the next scale of plants, already producing millions of liters of SAF, for example.
For a reasonable price, I assume.
Yes, it will not be fully there where we believe the potential is, because then you not go even one step more to 500 megawatt or 1 gigawatt.
This is something for the future. Energy systems change, you said before. Now a lot of data centers are producing energy on site or at site. What's in your opinion the change of the energy system overall? So how will your technology in particular and the energy system overall change in the future?
Again, I would say this a little bit depending on geography, but for Europe, I think it's pretty clear we need to produce as much as possible renewables on site. So I think that the rule should be direct electrification wherever possible because it's the most efficient and cheapest way. And that should be priority number one. And then, of course, there will be no other way. We have to import still molecules. And here, of course, it's important to switch from fossil-based to renewable molecules, which means basically hydrogen or biofuel feedstocks, whatever, could also play a role, but it's not scalable, right, as green hydrogen applications. So, of course, we need to push also bio-based feedstocks and fuels. And then for sure we need for hard-to-abate sectors hydrogen-based products. And here really I think important is that we have a very diversified supply base to avoid dependencies. And that's the big advantage of hydrogen, right? Oil, you can only produce oil where you have the resources. But hydrogen you basically can produce everywhere in the world with a reasonable solar and wind situation. Therefore, the supply base should be much more diversified. So, for example, countries where we have never imported energy will become big hydrogen producers, like India, like Chile. So there are lots of new players in the game, and I think there's a good way that they can really have a diversified supply of our future hydrogen products.
And go to also areas which are politically very stable.
Yeah, some of them, or most of them, let's see. But if we are diversified via broad scale, right? For example, from nobody we get more than 10% of our needs. I think that would be an ideal scenario.
Also, this improves the competition on the market. This will also bring down prices on the long term.
Sure, definitely.
Talking about industries, of course, we're talking here a lot of energy transition and fossil industry, but which industries, in your opinion, which we don't think about yet, could disappear because of this technology shift?
There might be some industries really completely disappearing, but I see transition is more important, right? I think we need the know-how of the oil and gas industry, right? I don't think they should disappear, honestly speaking. We need this know-how they have created in selling and making business with molecules. So I would see industries more transforming to a renewable business model than completely disappearing. Yeah, there might be some industries. For example, it's probably going to be hard in the future to run in Austria, for example, a heating system on molecules. I think there might be some niches, right, where simply electrification is the better way to do it.
Yeah. But with fossil, I meant more in direction of subsurface drilling and so on, which will be in the future maybe more focused on geothermal, and less on drilling for oil or for hydrocarbons.
Definitely, it's a diversification area for these industries. Yeah.
One industry that could face some certain changes is the fertilizer industry. You talked about green ammonia, which is a base chemical for this industry. What's your opinion there? What will be the changes of the industry for green fertilizers?
On the green ammonia fertilizer industry, it's actually, we see it already happening. There are already some projects with a financial investment decision to produce green ammonia for this kind of application. And I think we are very close there also that the business cases work. I think the fertilizer industry will be one of the first to move to hydrogen applications because the business case is very, very close to work. We see it even now. In particular, Asia is importing a lot of products from the Middle East, in particular ammonia and fertilizers. And based on the price situation at the moment in Asia, green fertilizers made out of hydrogen are today already cheaper than fossil because of the supply chain disruptions in the Strait of Hormuz, right?
Yeah.
So I think this is a very interesting industry. We are involved here. We are also applying the SOEC process because we can do the same, what I explained, before, just without the carbon molecule, right? So we can also couple an SOEC process with Haber-Bosch to go to ammonia as in a very important feedstock for the fertilizer industry.
So using the SOEC electrolysis for splitting of N2 molecules?
No, that we will not do. We are just producing hydrogen, so with the SOEC, so just hydrogen. Yeah. But the big advantage is why also this is extremely efficient, because we can reuse heat from the Haber-Bosch and, for example, vaporize the water with it.
High temperature, high pressure process with a lot of
there's a lot of exhaust heat. Yeah. We can use that in the electrolyzer, and we believe we can really get to efficiencies above 70% to produce green ammonia based on this process.
Which would be a game changer for the industry. Honestly.
Yeah, today you're in about 40 or 45%. Yeah,
it's almost doubling. With all these changes, all these developments, in your opinion, what will the world look like in 20 years from now?
So 20 years, we're talking close to 2050, right? So from the targets, I think we should be close to carbon neutral, right? According to the targets of the European Union.
You think this is realistic?
Yeah, it's hard to say, but no, I don't believe. But still, I think we need to make the right decisions, right? If it takes then 5 years longer or 8 years longer, that's not so important. But we need to make the key decisions we have to make in the next years
and get things moving. And they will improve over time anyways.
Exactly. Yeah. So I think we are, at least from a trajectory then, on the right path to getting to a CO2 neutral situation. I don't think from the absolute numbers we will be there where we should be. But I hope that, at least, as I said, the trajectory is showing in the right direction.
In the light of this, what's your opinion on the memo from the European Commission? They will review the green hydrogen legislation in June. What is your opinion on that?
Yeah, the industry is very split about that, right? There is one sector saying, don't change that again because this will cause further delays. Yeah. The other people are saying it adds too much cost, it's too complicated, we are not competitive with that. And in fact, both are right? Yeah. So it's a tricky situation, but considering global competitiveness, I think we should not completely skip these regulations, but probably we should introduce a little bit more time, a little bit more flexibility to it. So not changing it completely, but adding more flexibility to it, I think would help the industry to scale and really get to market.
So having a little bit more agile legislation could help the industry significantly.
Yeah, absolutely. For example, for this ESAF topic, there are really hard topics in this regulation with the CO2 source in particular, where the CO2 needs to come from.
And the electric power.
Electric power, that's even doable, but the CO2 is really difficult, right? Yeah. Because at the long term, the regulation only allows direct air capture or biogenic CO2, and that's really tricky for scaling ESAF production.
Having a CO2 source that you can use after 2035 and 2040 is essential. And nobody built such a plant with a business case for 5 to 10 years.
Exactly. It stops investments today, right?
Yes. And we need to get, as you said before, we need to get the ball running, and then we can look that it gets gradually more green. A few personal questions to you to summarize and to also end this talks. What personally motivates you to work on this topic every day?
For me, it was really the topic, as I said at the beginning, in living in LA, I got really excited about sustainability. Even at this point in time, now close to 30 years ago, California was the place to be for sustainability, right? It was the first country in the world introducing zero emission legislation for cars. So there was a lot of focus. It was not driven at all by CO2, it was driven by emissions, by harmful emissions. But nevertheless, it started there, right? And I got really, really very excited. And it's now still after 25 years, it's the really prior one in my professional life is doing my job, my contribution for a sustainable future.
What has been the biggest surprise in your journey yet?
I mean, there have been lots of surprises, honestly speaking, but probably continuously again is really what motivated engineers can do, right? Because we are facing very difficult situation in projects, but still, if engineers are also motivated from a sustainability point of view, doing their best, it's unbelievable what they can do. And so we have in all projects so far really met our targets. So it's unbelievable what can be done by solid and motivated engineers.
Mm-hmm. Mm-hmm. I can just sign that. That's really true. What would need to happen tomorrow for us to move faster on this topic? And if you could send one message to a politician, what would it be?
I have sent these messages quite a lot already, but so far it was not very successful. But nevertheless, I mean, I think there is one single measure, and the climate change would be solved. But it's very difficult to implement. But nevertheless, if we would have a globally harmonized minimum CO2 tax, climate change would be solved.
Mm-hmm.
Of course, it's super difficult, more or less impossible to achieve that.
Yes.
But nevertheless, right? If you would have that, it's done.
Mm-hmm. Mm-hmm. So you mean more like playing on a playground?
Exactly. So we would need actually we don't need all countries on board, right? But if China, Europe, and the US could agree on a minimum carbon tax, which over time is increasing, it could be even different absolute numbers, but we need a minimum, right?
So just relating to their
where they are in decarbonization, where they are in the stage, and it obviously there needs to be a mechanism that increases over time. With that, climate change would be solved in 5 years.
Mm-hmm. Mm-hmm. Honestly, this is a little bit depressing and motivating at the same time, because the solution is easy, but getting there is so hard.
I mean, in principle, we have these climate conferences, right? There is some progress there, but this one, of course, is really hard to achieve, in particular in a geopolitical situation we are right now.
Mm-hmm.
But nevertheless, theoretically, it would be easy.
Mm-hmm. What are you most looking forward to in the next 2 to 3 years?
So in the next 2 to 3 years, there are really big milestones coming up on our side. So as we were talking a lot about this co-SOEC technology, in the next 2 years, we are bringing 3 pilot plants into operation to really show that the whole thing works in an industrial environment over long durability. So that's for sure probably the most exciting for the topics we have addressed today, is seeing this technology getting really out in the field and doing its job, hopefully.
One last point for our audience. One takeaway. What is the one thing everybody should understand?
I think the key for me really is stress the point a lot. It has been said a lot, but it's not so much in our mind anymore. Climate change is real. It's a big threat. We should not be too concerned about CO2 taxing, because obviously what I'm suggesting is not CO2 taxing and by that increasing the overall tax situation, right? We have extremely high taxes on labor. We need to bring them down and bring up taxes on fossil energy. So balance that, right? I'm not talking about increasing taxes at all. It's just switching the way how we do the system. So so climate change is real, and the only way to really address it is CO2 taxing.
Great. Thank you very much for that. I will follow the developments of AVL and very much look forward to see this technology rolled out on big scale in the future. Thank you very much.
Thanks a lot for the invitation.